Hey algebras, here's the lesson that we started the other day but didn't get a chance to really dive into. So the good news is you already know how to do all of this. It's just at a more complicated level than you're used to. Here's some quick hints. Your first thing that I want you to think about is every time you are solving, the first thing you're going to do is set the equation equal to 0. And then you're going to try to factor. If you cannot factor, you're going to find a 0 by graphing and looking and asking Desmos to show you where the graph intersects the x-axis. Use synthetic division using the number that you got from here, and then you can reduce that polynomial by 1 degree. Remember, your goal is to get it down to the linear level or to something that you can work with in a quadratic state by either using the quadratic formula or completing the square or square roots. So you're going to keep doing this until you can break that equation down to that quadratic level. All right, remember to check your degree and make sure you found all of your zeros. So to help you remember this, great students really like dogs, graph, synthetic, leftovers, repeat, degree. Okay, here we go. Find all the zeros using synthetic division. So when I look here, I see 2x cubed minus 2. My first thing is that I'm going to set the equation equal to 0. I see a greatest common factor here. So if I take a 2 out, look at that, I'm left with the difference of two perfect cubes. Now I can divide each side of the equation by this 2 and just have my binomial and my trinomial. So here's the same sign, opposite sign, always positive. X, 1, x squared, 1 squared. And then you multiply x times 1 and that puts you with x. Now we know that we're finished here with this one, so we can go ahead and solve for our value of x here. And here's one of our zeros. Now when we look here, I know that this is prime because here's my binomial and trinomial piece. So my only way to get my zeros here is either to complete the square. I don't want to do that because taking half of b and squaring it leaves me with fractions. So I'll go ahead and I'll use the quadratic formula. So my a has a value of 1, my b has a value of 1, and my c has a value of 1. So all of the x's are equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2a. X is equal to negative 1 plus or minus the square root. 4 times 1 is 4. 1 minus 4 is going to be negative 3. And here is my imaginary root. So the best I can do here is simplify. Negative 1 stays put, plus or minus. The I comes out. There's my root 3 all over 2. So when we start looking at our solutions, I have negative 1 plus or minus I times the square root of 3 over 2. I started off with a cubic, and I have 1, 2, 3 solutions. 2 of them are here because of the plus or minus. All right, so if you have Desmos, feel free to go and graph this original equation and see what it looks like. When I put it into the graphing calculator, I'll just put it in as is, press graph, and I can see here's my one real solution. This turn, this curve here, is where my imaginary solutions are. All right, let's go on and do the next one. All right, so my first step here is going to be to set the equation equal to 0. I have to get everything on the same side. So I have my highest power is x to the 4th, then plus 2x cubed. I'm going to subtract 4x squared from each side. Then comes my minus 10x, and I'm going to subtract 5 from each side. So I have my quartic, cubic, quadratic, and linear terms all in descending order. Now, I don't see any common factors. This is just x's and this has no x's. So my only solution is going to be to graph it and see where it crosses the x-axis to know how I can chip away at this one x at a time. So I'm going to use my graphing calculator, but you are welcome to use Desmos. So I'm going to type in x to the 4th plus 2x cubed minus 4x squared minus 10x minus 5. Oops, look at that. So 4x squared, don't forget to arrow out, minus 10x minus 5. All right, so when I hit graph, I can look at this quartic equation, and I know I'm going to have a couple of zeros. In fact, I can see it crosses here, it looks like it bounces, and then it crosses. So it looks like I'm going to get 4 different zeros. If I go to the table of values, what I'm looking for is a 0 in the output. So I see I have 1 there. I don't see any others, but that's enough because that 0 will help me get down to the next level. So I know that -1 is a 0. So what I'm going to do is set up my synthetic division. I have the coefficient of 1, of 2, -4, -10, and -5. 4, 3, 2, 1, 4, 3, 2, 4, 3, 2, 1, none. Perfect. All right. Bring my first term down, and then I'm going to multiply, add, multiply, add, multiply, add, multiply, add. Now, I'm not surprised that this happened at all. I knew it because I knew that this was a 0. So if I didn't get a 0 here, then I would be in trouble. All right, here's my next step. I'm going to write my next polynomial. So what I did was I divided out one factor of x, and that's going to leave me with x cubed plus x squared minus 5x minus 5. All right, so I didn't see any other zeros, so it looks like my next choice, but I know that it crosses the axis at this place. I just don't know where. So what I'm looking at here is there another strategy? Is there something else I can do? So I have 4 terms. Let's try to do factor by grouping. So 0 is equal to, if I take out an x squared here, I end up with x plus 1. If I take out a minus 5 here, I end up with an x plus 1. So I have 0 is equal to x plus 1 times x squared minus 5. Check this out. -1 was a double root because 0 is equal to x plus 1, x is equal to -1. So I have 2 instances where it crosses the axis at -1. Look, there's my bounce. So that makes total sense to me that these are each zeros. All right, let's finish up and do the second part. So if I know then that 0 is equal to x squared minus 5, 5 is equal to x squared, take the square root of each side, so then x is equal to plus or minus the square root of 5. So let's talk about our zeros. X is equal to, let's list them all. I have -1, but that has a multiplicity of 2. That's a double root. I only list it once, but I know it's there twice, and that's where the graph bounced. And then here are my other 2 solutions, plus or minus the square root of 5. Don't worry about simplifying that. If you needed to, you can. Desmos gave you a decimal that does not terminate and does not repeat. It's an irrational number. So we'll just leave it in its radical form. Okay, let's check out this one. Remember, first step, we want to get everything set equal to 0. So 4x to the fourth plus 20x cubed minus 13x squared minus 59, ooh, and then plus 30 is equal to 0. So we went ahead and added 30 to each side. All right, let's pop over to the graphing calculator and see if we can find one of the zeros. So I have 4x to the fourth plus 20x cubed minus 13x squared minus 59x plus 30. All right, so I'm going to take a look at that graph. It's another quartic. So I have the potential for 4 zeros. Now I can zoom out and see where these curves and turns are, but really this is all I care about. So let's go to the table of values and let's see, there's 1 0 there. Oh, and there's a second 0 there. So really that's all I need is 2 zeros to get me 2 values of x that break down. So I can go right over here. I know that x is going to be equal to, I know at least 2 of my answers are going to be -5 and -2. But here's why I need to keep working. I don't know what the other 2 are. So these 2 answers are going to help me break down to 2 levels of x. All right, so let's do some synthetic division. I know that -5 goes in. My coefficients are 4, 20, -13, -59, and 30. Now remember, this is supposed to work, so I need to get a 0 here. I can predict that that's going to happen ahead of time. All right, ready? My 4 comes down, and I multiply -20, and I have 0, 0, -13. So when I multiply 5 times -13, check me on the calculator, I think that's positive 65, which is going to give me a value of positive 6, -30, and 0. Now, everything worked out here. I knew it was going to happen, no big deal. So I'm sure you're wondering, why bother? Because these are the coefficients that I need for my next level. This is the same as 0 x's, linear x's, squared x's, cubic x's. So what I have here is 4x cubed, and I can say 0x squareds minus 13x's plus 6. That's all equal to 0. That's my next level of my equation. So I already did this root, now I'm going to do this one. So I'll again, 4, 0, -13, 6. Put that through my synthetic division. -2. 4 comes down. -8. Positive 16. Positive 3. -6. No surprise again. If I get a 0 here, I know I did my work for synthetic correctly because I already know these 2 are answers. But here's what I care about now, is these leftover coefficients. These are my 0 x's, these are my linear x's, and these are my quadratic x's. So my next equation, 4x squared minus 8x plus 3 is equal to 0. That's my next starting point. Now I can't do any more synthetic because I don't have any more roots. And because I know it crosses but not giving me whole values, it's time to use the quadratic formula. Lots of quadratic formula in this lesson. My A is equal to 4, my B is equal to -8, and my C is equal to 3. So x is equal to the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. X is equal to 8 plus or minus the square root. Let's go ahead and get that value under my radical. 64 minus 4 times 4 times 3 gives me 16 all over 8. Check it out. We're going to get some pretty numbers here. X plus or minus 4, square root of 16 is 4, all over 8. So the reason I couldn't see these answers on the calculator is not because they're irrational, because they're just rational fractions. So I end up with 2 values that I need to find, and that's where this plus or minus comes into play. X is equal to 8 plus 4 divided by 8, and X is equal to 8 minus 4 divided by 8. So X is equal to 8 plus 4 is 12. 12 over 8 simplifies down to 3/2. So that's my next answer. 8 minus 4 is 4 divided by 8. That's going to give me 1/2. 1/2. So there's my 4 answers. My 2 that I got from the calculator and that I used synthetically to break down my equation, and then my quadratic formula gave me my other 2. And I couldn't see these on the calculator because they were fractions. You might have been able to see these on Desmos though. Alright, so that's it for the lesson. I'm going to stop here and then I'm going to record the practice on a separate video.